Now we have to find outliers. We have to do a little math to figure this out. And there's a reason that we looked at minimum, maximum, and range. The smallest number in this data set is 0.5. The largest number is 36.5. But can we actually use that in our box? What's the strategy? Well, the interquartile range is just the difference between the upper quartile and the lower quartile. So the difference between those two numbers, and if you look up there, you will remember that our upper quartile was 5.6 and our lower quartile was 1.2. Now if you subtract those two, 5.6 minus 1.2 is 4.4. That's where that number comes from. Now as long as we have 4.4, we now have a means to figure out exactly what our interquartile range is, and we can find some outliers. How do we do it? Well, the formula is to multiply 4.4 times 1.5. That's our interquartile range. So 4.4 times 1.5 is 6.6. Okay? Now, the next step, now hang in there with me. We take our lower quartile, which is 1.2, and subtract the interquartile range times 1.5, that 6.6 that we just figured out. So 1.2, our lower quartile, minus 6.6, the interquartile range times 1.5 equals negative 5.4. What does that tell me? Any values less than negative 5.4 are our low outliers, okay? Our low outliers. So if you look at this chart, I've already listed all the numbers less than negative 5.4, and you see how it's blank? There's nothing there. We don't have any low outliers. But let's look at the other side of this. Now, our upper quartile plus the interquartile range times 1.5, 5.6 is our upper quartile. And then we add that 6.6, 12.2. So any values above 12.2 are upper outliers. So let's look at our list of data. You'll notice 36.5 kind of stands out. Let me tell you what an outlier is. There have been classes where I've taken and the teacher has been so difficult that most people, if they take a test or a quiz, most people, including yours truly, would make a grade somewhere between 70 and say 80. But then there's that one guy that sits in the front and he's always raising his hand and he's always got the right answer. And it turns out he's the guy who's making a 100 on every single assignment. He's the outlier. Because what we don't know is that's the teacher's son and he's at home going through all the answers and talking to mom and dad about math and how to answer the next test and what to do in class. That's an outlier. That's what does not fit the rest of our data. All right. So in that example, this is mathematically how you come up with that. We've encountered outliers our whole lives. So anytime you have a fantastic quarterback, somebody who just stands out in what they do, that's an outlier because it doesn't fit the average. It doesn't fit the rest of the data that you see, okay? So the question now is, what do we do about the upper edge of the whisker? We can't use 36.5 because it's an outlier. You'll notice I've picked 6.4. The trick is to pick the number that falls below 12.2 but is not an outlier. What's the number that's closest to without going over 12.2 without being an outlier? And that's 6.4. All right. Yes, you can have more than one outlier on both the high side and the low side, but for this data set we've only got one outlier, and since the next lowest number 6.4 fits, we can use 6.4 as the upper edge of our whisker. Here's our number line. We're actually going to make this box plot now. Here's our number line. We have 0, 4, 8, 12, 16, 20, and we just count it by fours. So here's our symbols. The lower edge of our whisker, the lower quartile, median, upper quartile, the upper edge of our whisker, and our outliers, okay? And the outliers are represented by an asterisk. And the asterisk just sits off by itself because that's what an outlier does. It just sits alone. It isn't with the rest of the data. So all right, so here's our parts with all our numbers. And you'll notice the first thing I'm going to put down is the median at 2.6. And that's approximately where 2.6 sits, right there in that yellow. Now, let's move the lower quartile. There's our lower quartile at 1.2. All right. And let's move on. Upper quartile at 5.6. Now we have the lower edge of our whisker, 0.5. We have the upper edge of our whisker at 6.4. And our lonely outlier at 36.5. And you notice I filled in our box down there. So there's our box and our whiskers right there. And you notice I've labeled each one of those parts. And that's basically it. That's how you form a box plot. But this isn't just a box plot. This is a double box plot. So tune in tomorrow for part 3, where we talk about the next section of this. All right, now I know I'm taking my time with this, but that's on purpose. Everything we do from now for about the next week and a half are all plotting box and whisker graphs. So I'm taking my time with the first 3 parts so you guys have a good introduction on this, and then I'm going to go through it, like I normally do. All right, so you all take care, and thank you so much for joining me, and I will talk to you soon.